Why, hello there. This is the Cassette Master, and welcome to this video. This video is about the various more common types of non-volatile memory chips, in which we will be showing the ROM, the PROM, the EPROM, the double EPROM, and flash memory, as well as a bonus showing of zero power RAM, or battery-backed random access memory. We will also be showing devices that will program these chips, as well as an EEPROM eraser. I hope you enjoy this feature presentation. Here, displayed, are various types of non-volatile memory. This particular chip here is strictly read-only memory, or ROM. It also known as masked ROM. The actual memory is programmed permanently at the factory and cannot be reprogrammed or erased. Hence, masked, because it is in the mask used in the last process of the manufacturing of the IC itself where the data pattern is put into the ROM. These two chips here are examples of PROM, or programmable read-only memory. With the programmable read-only memory chips, a user could program their own data onto the read-only memory. But here's the catch. You can only program it one time, because inside there were basically microscopic fuses in the silicon, such that whenever you would program a bit, it would blow that little fuse. So each bit was one microscopic fuse blown. Both of these chips are only 32 bytes apiece, although there are some other variants made as well. I have some more PROMs, for example, that are 512 bytes apiece. These two chips here are very special. They are EPROMs, or erasable programmable read-only memory. You'll notice that these EPROMs have a window on them, and you can actually see the silicon chip inside. These windows are made out of quartz as opposed to glass, to allow ultraviolet light to penetrate and reach the silicon. The chips were programmed by the user and could be reprogrammed, but to erase, you would have to shine ultraviolet light onto the die for 20 minutes. Then there's the double EPROM, or electrically erasable programmable read-only memory. The double EPROM operates similar to an EPROM, except instead of erasing it with ultraviolet light, it would be erased electrically, and therefore it does not require a dedicated eraser. Then there's flash memory. Flash memory is the kind of memory you see oh so commonly now in the ubiquitous thumb drives seen everywhere these days. Flash memory is very much like the double EPROM, in which you can erase flash memory electrically and reprogram it. Although I believe flash memory would erase chunks of the data at a time, whereas double EPROMs you could erase individual bytes at a time. Well, some of them you could, for instance this one. But this one you had to erase the whole chip as a whole. Then here is NVRAM, or Non-Volatile Random Access Memory, which is irregular old volatile RAM, except there is a built-in lithium battery which will supply power, a very small amount of power, to retain the data on the chip. The original use this one had that's amongst my components was used in a race driving arcade game to store high scores. Of course, their uses are far more than just to store one's high score. Then I want to show you another chip. This chip is like a PROM, in which you can only program at one time. But also, it is like an EPROM, because that is the 1E, the erasable programmable read-only memory, because this particular chip actually contains the silicon die of an EPROM, but in an opaque package for cheaper manufacture. And therefore, since you can't get UV light on it to erase, it's not erasable. Therefore, it's known as a OTP EPROM, or one-time programmable EPROM. Notice that the actual EPROM has a ceramic case. The reason why the EPROMs used ceramic housing was because the expanding and contracting with temperature of the quartz and the ceramic went together well. With plastic and quartz, things wouldn't go so well, although there are plastic EPROMs in existence. The Soviets did manufacture plastic-cased EPROMs, as you can see an example right here. Fascinating bits of technology these chips are, all to serve one purpose: to retain digital information even when power to the circuitry is removed. The use of the ROM was mainly used for storing program data. It was commonly used for storing the BIOS to start a computer. Also, cartridge-based video game systems would use masked ROM chips. BIOS generally used EPROMs and, in this example, flash memory. This example coming from 2001. EPROMs would also be used to store the program information for arcade games, and also for various different industrial equipment and other different electronic devices. Non-volatile memory is a very fascinating thing. And now, let's show some more equipment related to non-volatile memory, mainly EPROMs. Here is an EPROM programmer, which can program digital information onto quite a few different types of non-volatile memory, including the PROM, the EPROM, the double EPROM, non-volatile RAM, programmable array logic, general array logic, and also can program onto the non-volatile memory of a microcontroller. Oh, this tripod I hate. Notice here the zero insertion force socket. At the zero insertion force socket, you can see that it shows that the EPROM must be put into the programmer with the base at the bottom, and then shows where the top goes for various different pin counts. We're going to show the reading and writing of information onto some of these chips. Although the EPROM programmer is unable to program onto a masked ROM for obvious reasons, it can still be used to read the data off of a masked ROM if needed. Oh, I've copped one. The masked ROM is then put into the programmer, and the zero insertion forces lever pulled down in order to lock the chip into place. When you're reading a masked ROM chip, some creativity has to be taken into account because the EPROM programmer's chips that you can choose from don't include masked ROMs. So I have to find an EPROM chip part number that has the same pinout as this masked ROM. This masked ROM was a 23C4096. I found the 23C4096 datasheet easily on Google. I then, knowing that EPROMs tend to have a 27C model, while masked ROMs tend to have a 23C, by the way, EEPROMs tend to be 28 and flash memory 29, I figured I would search for the 27C4096, but found out that the pinout to the 27C4096 was different than the pinout for the 23C4096. But seeing how it was a 256K by 16 configuration chip, I searched a 4 megabit EPROM online that was 256K by 16, and found the 27C4002, which does have the same pinout as the 23C4096. Of course, this showing it with a programming pin where it's not connected on the masked ROM for obvious reasons. So now on our trusty software, we can look up the 27C4002, and there it is. Then we will do a read. Manufacturer's code unmatched, ignore. And we're reading from the masked ROM. Now that we've read from the masked ROM, we can actually look at the data. And the fun part is to find various different ASCII strings that are hidden amongst the myriad of data. Sometimes the bytes are swapped. And that is an example right here on this 16-bit chip. Notice amongst the ASCII here, you can probably tell that says product. If we do a swap, we'll see that the strings are fixed. Now we can happily read some of the stuff that the chip has to tell you. Dial, wait, tone, test, disable, Control S to stop, Control C to cancel, transmitter, help, care, carry, call, duration, clock, answer, hook to product, analog, loopback, test pattern, mode, reserved, chars, octets, block, sent, lost, link, retrains, received, volume, bit mapped compression, data. There's various different things this chip has to tell you. It's even got things for setting the different baud rates for the device that this chip came out of that I took apart many years ago. It's just quite something to see reading from that masked ROM. And that's one of the joys about reading stuff out of old chips. Okay. Now that we've read from that chip, let's read from a PROM, a programmed PROM. Now we select the 82S123. Oopsies. 123. It's a PROM. Read it. Doesn't take long to read. It's only 32 bytes long. At some point in the past, because there was a tiny amount of blank space on this old junked PROM, I decided to program on it the word PROM. Go back. What do we have an EPROM that we want to program? Well, the first thing we need to do is to make sure it's blank. We can do an auto ID to automatically bring up the identification of the chip with ease. This one being a 27C64 or an 8 kilobyte EPROM. We'll do a blank check. Device is not blank. We do a read. And then we go to the edit and we can see the information that is currently on this particular chip. We can see there's some ASCII at the end. Let's see what this ASCII tells us. This IC contains linear predictive coding data of Mike Lynch interviewing Ricky Klein about school. It was recorded in 2006 for the TMS5220 synthesizer. We're going to first save that file before we erase the chip. A binary file. Now, we want to program our own information onto this chip. But it is, alas, programmed. The only way we can erase it is with the special UV eraser. Here displayed is the PE140T EPROM erasing ultraviolet lamp manufactured by Spectroline. You can see it has a mechanical timer at the top, and you can see that it has a tray. You can see there's already a couple EPROMs loaded in it. You can put several EPROMs in there. It even has that foam already in there, the anti-static foam. Put the EPROMs into the eraser. Then set the timer to about 20 minutes. And turn on the ultraviolet lights. A small window is displayed, which is opaque to UV, so it won't hurt your eyes to see that the light is there on the window. But you do not want to have the ultraviolet light of this running with your naked eye, because the ultraviolet light to your naked eye not only can greatly damage your eye and even blind, but also can damage skin. Pretending the timer is up, you can remove the chips and program away on your EPROM. Auto ID. This is a different chip. It should be blank. It is blank. And then you can go into edit. I gotta read first. Read. Oh, goodness. Sometimes I don't get a good connection on this thing. We got to reseat the chip. try it now. Edit. And you can see it's all FF or 1s. I could program just some text in there. And then program. And then read it again and go to edit, and you'll see officially programmed onto the EEPROM now this is a test. Just imagine if we had to use this EEPROM programmer instead, built from a magazine article in the 1980s. It programs only one kind of EEPROM, the 2716, a 2 kilobyte example, and will only program the EEPROM 1 byte at a time manually. Well, viewers, I hope you enjoyed this crappy, amateurish video on non-volatile memory with an emphasis on the beloved EEPROM. Shot on the 18th of February 2018, ending shooting at 4:40 p.m. Eastern Standard Time.